pleased to introduce Skip Pruss. Skip has been instrumental in the work to decommission Line 5. He's a former board chair of FLOW, as well as the former director of the Michigan Department of Energy, Labor, and Economic Growth under former Michigan Governor Jennifer Granholm. And Skip is going to be welcoming and introducing Peter Sinclair today.
Morning, everybody. I first reached out to Peter in 2008 after discovering and immediately subscribing to Climate Crock of the Week, his video program. That was 13 years ago, and if you think about it, climate denialism was far more rampant, particularly in this country, and a lot of other people thought if they weren't denying climate, they thought it was an interesting theory. So Peter's work took on climate deniers who misrepresented the science, and he would deconstruct their arguments to devastating effect. His in-depth explanations of climate science, climate denialism, and climate myth debunking were unique. No one, I checked around, no one in this country, I believe no one in the world was doing this kind of work at the time. His video productions, they were edgy, they were irreverent, they were stylish, they were entertaining. And he was doing it all in his spare time and on his own dime. Now, Peter's audience was really small, but he had this faithful and abiding following by climate scientists. I mean, they loved Peter's work, and they still do today. And that's why Peter has this tremendous access to the leading climate scientists around the world who, volunteer their time to help Peter produce his work. And so Peter continues to inform us about the nuances of evolving climate science in the most clear and concise ways. He presents to scientists at the American Geophysical Union's annual meeting. They love to hear from him. Peter was the videographer or documentarian for the Dark Snow Project. He would fly to Greenland and document how soot from forest fires and particulate pollution was darkening the surface of Greenland, their ice sheets, which resulted in more solar energy affecting the ice sheets and ultimately accelerating the ice melt. Peter does This Is Not Cool for Yale University for their project on climate change communication. And Tree Hugger has long referred to Peter as the sharpest climate denier debunker on YouTube. And finally, the National Center on Climate Education stated and awarded Peter and recognized him as the most important videographer on the planet. So Peter's a national treasure, and we're really fortunate to have him here in Michigan. Peter?
Thanks, Skip. Can you all hear me? Can everybody hear me?
Yeah.
Yes.
Okay, very good. I am going to share screens as soon as I can find my. Okay. Very good. Thank you so much, Skip. And Skip has been an absolutely invaluable ally and resource and continuing fountain of good information for me to tap. So I couldn't do this without allies like Skip. Thank you all for coming. It's a beautiful May day. We're going to talk about some serious matters here. As Skip mentioned, I've been doing videos on climate change and energy solutions for quite a while. And I did early on find that I had a big audience in the science community. And that's been one of the most gratifying things for me over the last 10 years. They've started to invite me along with them to some of the more extreme places on the planet where climate change is actually occurring. 2012 was the year I went to the Northern Cascades in Washington, Easton Glacier and Deming Glacier. In 2013 was my first trip to Greenland. That's my colleague, Dr. Jason Box of the Danish Geological Survey and Mackenzie Skiles of NASA working there. I went there for 6 years in a row. I've missed a couple years here, obviously due to COVID. This was our camp captured by a NASA satellite in 2014. I was lucky enough that year to camp on the ice for an extended period of time. So that was a huge breakthrough in my understanding of all these issues. What we were looking at in that year and since then is the meltwater that's happening on the surface of Greenland. Greenland is an ice sheet 3 times the size of Texas, and what happens there means a lot to all of us. What I'm doing here is not fishing. I'm holding a camera over one of these very large, what are called moulins, places where meltwater flows into deep into the surface of the Greenland ice sheet and then out into the ocean. And that's going to be relevant to some of the things I'll be discussing later in this presentation. But to begin, I think 2020 has showed us that nature has some pretty devastating tricks up its sleeve. It's also showed us that we have some amazing technological ability to respond when nature throws us a curve. And in this case, in the form of the vaccines and treatments that we have been able to deploy. But one of the really interesting things and how this compares and relates to climate change is how we've been unable to come together as a community on the science so that we can agree on what the solutions are to these problems. And it's because we have a massive disinformation apparatus that is crippling our democracy and might ultimately destroy our democracy. This is maybe one of the key problems of the age, even before we can begin to deal with climate and so many of the other issues. So the first video I'm going to show is part of my This Is Not Cool series that I do for Yale Climate Connections. And this was the first video that's ever gotten me into YouTube jail. Because I used footage of some of the principal purveyors of misinformation. They must have some kind of a AI algorithm that picks up on these things, and they made it impossible for anyone to view the video without identifying themselves. Even someone even told me he had to upload a photo ID to be able to watch this video. So apparently the social media giants, having left the barn door open for like way too long, are now making it harder for people like me to try to set the record straight. But I'll play this for you. I think it's relevant to our discussion and shows us something about the depth of the problem here.
How did we get here? When did Americans begin to disagree not just on priorities, but on the fundamental universe of facts?
None of this alarmism about ice and heat waves and drought, none of it is happening.
What does it mean that the richest, most powerful industry the world has ever known has devoted 4 decades to undermining belief in science and fact?
If you can distrust the scientists at NASA, that any authority is not correct, right?
At what point in your life did you stop listening to the mainstream narrative?
When I realized that doing my own research brought me more information than listening to the news ever could.
Do your own research in this context is always code for go onto Google and confirm your own biases, right?
Heather Simpson is a 30-year-old mother in Texas. She says she was introduced to anti-vaccine conspiracies by watching a documentary series she found online.
When you were in this world of anti-vax, did you just assume your pediatrician was wrong, that everybody was just wrong?
Yeah. These anti-vaxxers believe they have this secret knowledge that the world's top scientists don't know. Like, we know it and they don't, and that makes us pretty cool and special.
Did it make you feel cool and special?
Of course, yeah.
It's a kind of rebellion. It's kind of like saying, well, you say this, but I can believe the opposite, and you can't stop me. It is a very kind of like toddler way of kind of exploring the world.
The initial PR guys for the oil industry, were trained in psychological warfare by the U.S. military, and they came home and put those skills to work first on behalf of tobacco companies and almost at the same time on behalf of oil companies. And they were very good at it.
For cooking and for dancing and kissing, you satisfy best. But for filter and taste, Ken satisfies best.
I'll accept that. Unfortunately, what that's created in the meantime is a large-scale disinformation system that can be used to any number of ends.
Years and years ago, before Trump, it was a mainstream position in Republican Party politics to think that climate change was some sort of new world order conspiracy by the UN to take over the American political system and infringe on freedoms.
Communist corporations, elitist politicians, and reckless scientists have contributed to creating a phony crisis.
Top scientists in the U.S., England, Europe, and at the UN colluded together to defraud the public, to lie to the public, and to terrorize the public through this fake environmental crises into giving control over their national sovereignty.
And to transfer government to a new global entity based on the UN in the name of saving us from the climate destruction and of the latest phrase I think is called sustainable development.
But if you just start paying attention to what the discourse on climate change has been like, then I think that the last 4 years makes a lot of sense.
Over decades, the climate deniers have broadened their reach to include a variety of conspiracy theories, casting a fog around the simplest and most fundamental issues.
And I have concluded that what one needs to have is a freshly minted Hawaiian birth certificate.
Some of the people who push denial of the fundamentals of climate science were out there saying that coronavirus is overblown and that masks don't work.
COVID-19 is a power grab hoax. COVID-19 is a scam.
If you are wondering why a lot of people distrust science and institutions, why they don't trust the CDC to provide them advice about mask wearing and a virus, I mean, look no further than 4 decades of denying climate science.
And the work of powerful forces to create their own reality is really nothing new, but the power of social media, I think, has helped accelerate it.
There is an infrastructure, particularly online, that is setting about radicalizing a whole swath of different kinds of people. We're talking overwhelmingly about Facebook here. The algorithms built into Facebook are designed so that if you click extremist misinformation, it's going to send more of that your way.
These groups get sort of targeted, and then they get hammered with climate denial for, a decade or so. So then by the time it comes around to school shooting hoax theory, they're like, yeah, I could see that.
Sandy Hook is a synthetic, completely fake, with actors, in my view, manufactured. So don't ever think the globalists that have hijacked this country wouldn't stage something like this. They kill little kids all day, every day.
People high up in the Central Intelligence Agency have told me that there is a cover-up of Sandy Hook.
The more that we were able to treat information as a smorgasbord and, and pick and choose exactly what we wanted, the easier it became to just, choose your own reality.
The problem is that a lot of people, they consume media like this. They choose which media source makes them feel the best. They view it as like, I don't know, getting a massage or something. The best masseuse is the one that makes you feel the best. And in this case, they feel like the best news source is also the one that makes you feel the best.
I think more journalists who maybe have no personal expertise in climate science are starting to be comfortable with the fact that if you're denying climate change, you're part of a disinformation ecosystem that I know about already, even if you sincerely believe it. That's also been a lesson of the Trump era, I think, is that it is not just the responsibility to get both sides of a story, it's to evaluate the evidence of both sides and present the truth.
So that's what'll get you banned on YouTube these days. So climate, our concern about climate is in large part based on the speed of the change that we're currently observing. And of course, this is footage from The Day After Tomorrow, the 2004 movie, which is wildly over the top and completely science fiction, not to be taken seriously. It's an entertaining movie, and I often say it's probably the best Dennis Quaid movie ever. But there is a grain of truth here in that we're entering an era where sudden changes are potentially in the offing, and sudden nasty surprises. In 2015, my colleague, Dr. Box, teamed up with Michael Mann and Stefan Ramsdorf, senior climate scientists globally known, and produced a concerning paper talking about possible sudden changes in ocean circulation related to climate change, and in part related to the increased melt that I spoke of that we're seeing off of Greenland that is going into the North Atlantic. And in recent years, that work has been expanded and confirmed. Washington Post recently reported on some of the most recent concerns about the impacts of these changes in what we would call the Gulf Stream, but which is really part of a global oceanic flow. And I did an extended interview on this in Greenland in 2017 with J.P. Stevenson, who is probably one of the most senior experts on ice sheets and the history of ice sheets and what those records show us. And he spoke about his concern that we could possibly be entering an era of climate instability brought on by the greenhouse gases that we've been forcing into the atmosphere. So this is a piece called "Rats in the Experiment" that I think illustrates one of the major concerns that we have right now: sudden changes in natural systems that could possibly be occurring.
The last 11,000 years, that's since the Ice Age, this our interglacial period has been unreasonably stable. And we don't know why. With an enhanced greenhouse effect from burning of fossil fuel, CO2 and methane and so on, you would have a gradual increase in temperature. That's what all the models show you. It's sort of a gradual increase in temperature. But that's assuming that the climate plays nice. And we actually know from the ice cores that the climate does not play nice all the time. Right now, by emitting greenhouse gases, we are doing the same with the climate system as the investment banks in the US did when they were selling subprime loans in the economy in 2006 and 7. In the last million years, there's been a cycle of approximately 10 ice ages. And they were sort of around 90,000 years long, each of them. And then there was an interglacial period separating the ice ages of about 10,000 years.
That's sort of the standard rule of events in the last million years. If we then zoom in on an ice age, you see that inside an ice age, the climate is extremely unstable. And you have this sequence of abrupt climate changes that happen basically from one year to the next. And it swings from semi-cold to very cold, semi-cold to very cold, within very short spaces of time. But each of these cycles is about a couple of thousand years long. And we had that 26 times in the last ice age. All the big cultures in India, China, Mesopotamia, Egypt, South America, all came after the ice age. So we are assuming that this is the standard. Our collective memory refers to this as this is normal. And maybe by enhancing our emissions of greenhouse gases, we are actually tipping the climate system to become yet unstable again as it used to be. We can face a climate change that happens just as sudden as a financial crisis. We have tons of examples of climate changes where we see complete reorganization of the atmospheric circulation from one year to the next. And that will be extremely hurtful for any agricultural activity in the world, because the weather will change and will not change back. Fast climate transitions, these abrupt climate changes that we see recorded in the Ice Age, they were discovered in the Greenland ice cores. But now they keep finding them everywhere in the marine sediments, wherever they look. But when it comes to Antarctica and the Southern Ocean, you don't see them. What you see there, it's also a wiggly climate line, but opposite. So when it's warm in Greenland, Antarctica cools off. And when it's cold in Greenland, Antarctica warms up. So these abrupt climate changes, it's an internal oscillation in the Earth climate system. What if what we do now is introducing so much fresh water into the North Atlantic that the North Atlantic current would sort of stop? That would make it terribly cold in Denmark, where I come from, because all of Northern Europe is placed at completely unreasonable latitudes. Just because we have the North Atlantic current, we have remote heating, so to say. If that's going to be switched off, we're getting very, very cold. But still, the Earth could get warmer on average. It's just a distribution problem now. In principle, there's no reason why the Earth could not get warmer, but still Northern Europe and North America could get cold. Still, that area is not large compared to the global area. What we know from the sudden climate changes in the past is that these abrupt changes represent a reconfiguration of the entire atmospheric pattern. What if, with the emission of greenhouse gases, that we trigger a situation when this system all of a sudden goes into a feedback? If you reconfigure the transport patterns of high pressures and low pressure systems over North America and, for instance, Europe, but particularly North America and the Midwest, and all of a sudden it stops to rain, and it hits the Midwest in the US, and it leads to massive crop failure, that's going to impact the entire world. We don't know. We don't know what the threshold is, but we are rats inside the experiment.
So the concern that Dr. Stephenson has, and a lot of other scientists, is about systems like these, like the North Atlantic current, that could change suddenly. But there are also human systems that have been built over the last 50 or 100 years that were essentially built to a different set of assumptions than what the current state of the planet is. Last year, in the spring of last year, I had my tickets booked. I was going to head to a place called Svalbard, high up in the Arctic. And then suddenly everything was shut down for COVID, obviously. But climate change came to me. in Edenville, which is about 20 miles away.
There it goes.
Extremely heavy rains.
There it goes.
Which are becoming more frequent. We had first one dam collapse, the Edenville Dam, and then that lake flowed down into Sanford Lake, which is below.
There we go. There's the rush.
Sanford Dam was then overtopped, and the city of Sanford was destroyed, small city. 10,000 people had to be evacuated. A large sections of Midland were flooded, which is becoming an increasingly frequent event. And it turned out that I had just had done some interviews with senior scientists related to these kind of issues. The problem that we have in the central part of the United States, we don't have to worry about sea level rise, obviously, but we are seeing more extreme precipitation events. And I think anybody that's certainly over the age of 40 or 50 will tell you that we're seeing more of these intense rains, delivering a lot of water in a very short time than we can remember from long ago. And so I did a piece kind of examining this issue, and you'll see Carrie Emanuel, very senior atmospheric expert at MIT, my friend Andy Dessler from Texas A&M, and a few other scientists as well, sort of explaining the mechanics here and what it means.
Where climate change gets you most is when you take, say, a 150-year event and it suddenly becomes a 50-year event. And that's sort of what's happening in many places.
The atmosphere now in general has about 7% more moisture in it than it did back in, say, the 70s. There's very clear evidence that all across the United States, especially in the eastern half of the country, we've seen a big uptick. I mean, I'm talking 30, 40, 50% increase in the frequency of heavy precipitation events. This is very directly connected to climate change. It's totally expected. And it's certainly playing out in real time right before our very eyes.
So I grew up in a neighborhood called Meyerland in Houston. And when I was there, Meyerland never flooded. Now it floods all the time. And I went on Zillow and I was looking at houses and I found this beautiful house. It's 5,000 square feet. It's located in a nice neighborhood, good schools. And it's selling for $86 a square foot. It has a pool. I mean, it's really a beautiful house. And if you say, wow, why is it so cheap? It's because it's flooded twice. And so no one wants to buy this. No one wants to buy a house that's going to flood.
And the example I have in mind is Hurricane Harvey of 2017. And 3 independent groups who did not know about each other working on this, one of which was me, estimated that the risk of that level of rainfall in Harris County had more or less tripled between 1970 and 2017 when the event occurred.
And if you'll notice, it says would be a great candidate to lift. So I'll talk about that in a second.
It's going to rain harder on average, so you're going to see more of the type of rainfall events capable of causing extreme flooding.
The 500-year flood event, which are, of course, becoming more and more frequent. We've got climate change as a part of that, but also old infrastructure as well.
As far back as 1999, the feds warned that the dam needed to increase its capacity to prevent a significant flood from overcoming the structure.
And we have a lot of things that we've built that may be vulnerable to a gradual change, pushing them over a threshold and causing an abrupt issue for us.
Climate change is this constant pressure on our society affecting
millions of little decisions affecting our lives in millions of ways, each one of them making us a little bit poorer than we would otherwise have to be. You know, if you live in the Gulf Coast, you're gonna have to run your air conditioner more. You're gonna have to pay for flood infrastructure. You're gonna have to pay to raise houses off the ground for new construction. There are just millions of these little costs that are going to be pushed into all of our lives.
You know, the average storm you might encounter every 10 years or so isn't changing very much, but the 100-year event is becoming noticeably, in many places, noticeably more risky.
A heavy rainfall event that would have occurred about once every 100 years on average in a world without human influence is now occurring about once every 20 years on average. And if we continue warming at 2 degrees of global warming from pre-industrial, that same precipitation event will be occurring about once every 5 years on average.
This is not any longer a problem about the future, it's a problem about now.
The entire swath of states from North Dakota to Michigan had their wettest year on record in 2019, and we had just amazing amounts of flooding.
Water vapor is energy. Think of it as energy. When that water vapor condenses into liquid, which happens in a cloud, that latent energy is released into the atmosphere. So that provides even more energy for the storm to work with. So when it does rain, it rains harder.
The danger of flash flooding is actually increasing, and it's not just because of heavier rains. It's also because of heavier real estate development.
It would have been called a 1,000-year flood if the same destructive deluge hadn't crashed through Ellicott City, Maryland just 2 years before.
You had two 1,000-year floods within 2 years of each other. How did that happen?
The overwhelming factor was intense rainstorms. More water is falling. On top of that, we're intensifying land use, which is clearing the natural vegetation and replacing it with impervious surfaces like concrete, asphalt, through which water does not penetrate.
So you know, I don't know who the owners are, but I know they've lost a lot of money. And so they've lost a lot of wealth. And this is a fundamental problem, this idea of what we call stranded assets. So you might own something. It might be an oil field, it might be a coal mine, it might be a house that floods. And then one day you wake up and it's not worth anything, or it's worth a lot less than you think. And that's a really socially destabilizing problem.
The first degree of warming doesn't cost very much. The next degree of warming costs a little more. The next degree of warming costs more than that one. The next degree of warming costs more than that one. What we face now is very small compared to what we could face if we keep burning all the fossil fuels we can get our hands on.
So climate change is starting to cost us money. It's a subtle tax on all of us. As more and more of these calamities pile up, for instance, in 2017, $136 billion in these weather disasters had to be appropriated to help people recover. The average number of billion-dollar events doubled during the past 5 years as compared to the average over recent decades. So climate is going to impose a tax on us. One of the solutions that people talk about is a carbon tax. And the rationale for that is, you know, we're gonna get taxed one way or another. Perhaps we should consider a tax that might push us in the right direction towards a solution here. And the housing market in particular is vulnerable to this. Over the past year, what we've seen in Midland, you saw in that video, a pretty nice neighborhood that had obviously been devastated by the flood. Those people have lost a lot of money. I've heard stories of there's an extremely well-heeled neighborhood that has now been repeatedly flooded several times, and heard one instance of a house valued at $1,300,000 that sold for $300,000. And I'm particularly concerned about not necessarily the $1 million people, but what about the $100,000 people? And how much are they losing? Did they know they were in a floodplain? Maybe they weren't when they bought the house, but now they are. And so these kind of economic losses, as they pile up, begin to create their own sort of ripple effects on the economy and can create economic disasters in their own right, making it harder for borrowers to make mortgage payments if their homes are not just financially underwater, but literally underwater. And one of the most recent examples of this we saw, which, we don't have the forensics yet on the Texas event, the Valentine's Day freeze that descended over most of the American U.S. heartland, but especially severe in Texas. And what we saw there was a grid that was not winterized, not prepared for this kind of event. And we saw more than 100 deaths, close to $100 billion and counting in damages. So I just put together a short video kind of explaining that event and what happened, because there's been a huge, and it is ongoing, an attempt to say that event was caused by renewable energy, and it is not the case. So I spoke to experts at the University of Texas, at Rice University, leading journalists in the state, and in particular followed the fantastic coverage from the Dallas and Houston TV stations on this, which, if anybody's doing a paper on this is a great place to start, is KHOU in Houston, WFAA in Dallas, KVUE in Austin. But I'll just run this for you and you can see what they told me.
4 minutes and 37 seconds. ERCOT revealing tonight that's how close Texas was from a total collapse of its power grid.
What we saw in Texas, was a colder, deeper, wider amount of weather that we've really, ever seen. We've had cold weather and we've had events that have led to failures before.
We had really bad deep freezes in Texas in 1983, 1989, 2011, and 2021. And each one strained the grid and led to blackouts of one sort or another. But it feels like a replay of 2011 in terms of power plants tripping offline, the natural gas system freezing up, the gas freeze-offs causing more power plants to go offline, and then you have like a water crisis and this kind of thing.
As several power plants around the state failed, Central Texans faced ongoing electric blackouts as ERCOT cut off power across the region, neighborhood by neighborhood.
The feds had warned Texas of poor winterizing plans a decade ago after another big freeze crippled the state. But recommendations in this report, FERC's new chairman says, were largely ignored.
But this one was colder and wider and longer, lasted longer than previous events.
All 254 Texan counties have imposed a winter storm warning. That's never happened before.
As the cold Arctic mass came in, is we saw an extreme increase in the demand for heating in Texas, as everyone was wanting to stay warm. About 60% of homes in Texas use electricity, 40% use for natural gas. And we just saw like an extremely high amount of heating. Now, we meet peak demands like this in the summer all the time. The difference between this event and that event is there was competition in the natural gas system. So while power plants were wanting to consume natural gas to make that electricity, homes were also wanting to consume natural gas for heating. And at the same time, our supply out of West Texas, we had some wells freeze off, some gathering lines freeze, and we weren't able to put more gas into the system, and we ended up short on the natural gas system. So some power plants couldn't get gas. Some other power plants also had freezing issues with cooling water or sensors or all kinds of things. When it all came down to it, we lost about 40% of our thermal fleet during the time when, we were, demanding the most amount from both of these systems.
Transmission connections between Texas and the rest of the United States
are really pretty limited. So it's difficult for other places in the United States to come to their aid by shipping power.
Every source of power that the state of Texas has been compromised.
The entire natural gas system from the wellhead to the power plant really just broke down.
Access to coal generated power, access to gas generated power also have been compromised, whether it be with regard to systems freezing up or equipment failures. It's just frozen right now. It's frozen in the pipeline. It's frozen at the rig. It's frozen in the transmission line.
So,
and
Governor,
so they are incapable, the natural gas providers are incapable of being able to come up with a gas that feeds into the generators that generate the power that will send power to people's residences there in the Dallas area, as well as our nuclear power facility.
One of the lead reasons in the Houston area in particular that caused power outages is the South Texas nuclear project was shut down because of an operational difficulty.
Comanche Peak, which is a nuclear reactor, was within just minutes of going offline. And if that had happened, we really could have had a blackout.
By far the biggest piece, the piece that overwhelmed every other piece of the story is the way that the gas systems and the gas electricity wasn't there when we needed it.
Actually, it's more their natural gas plants that have been affected by the cold weather than it is their wind.
And wind turbines had their trouble with ice on blades, but wind wasn't the biggest problem for the grid. The biggest problem for the grid was the frozen thermal plants, the plants that use coal or natural gas or nuclear that really didn't show up to perform.
You'll hear the people who talked about the freezing of the wind turbines. It was a very small percentage of the power generation that was lost in Texas from renewables. The vast majority was from baseload generation.
During the daytime, solar was the one thing that far outperformed and gave us way more power than we expected.
It's a complex set of factors, but what we know right now is that the wind power plants are mostly meeting their expected performance levels. But what is not happening in Texas is that many of the thermal power plants, the plants that boil water to make electricity, like natural gas-fired power plants, coal-fired power plants, and at least one nuclear unit, are not producing energy. They're suffering outages, and that dwarfs the amount of wind resource that's not performing right now. So it really is a traditional power plant problem, not a clean energy problem.
I and many others have been telling them for years, you should be starting to think about extreme weather events that we know are getting worse, demonstrably, regardless of your viewpoint on climate change and cause. Texas is in the gun sights for an awful lot of extreme weather, and extreme weather is getting worse and worse. We designed this entire grid for Ozzie and Harriet weather. We are already facing Mad Max, and it's getting worse.
So among the people that are getting concerned about these kind of events and their increasing frequency is not just scientists, but people who actually have money in the game here, insurance companies. And I had a conversation about a year ago with Andy Hoffman at the University of Michigan Business School, who has been tracking this. And I think his remarks are germane here.
There are also market shifts in play that are very important. And the one I watch very closely is insurance. As we start to have wildfires in California, storms in the Southwest, flooding in the storms in the Southeast, flooding in the Southeast. Insurance is watching this very, very carefully. The Society of Actuaries did a survey last year, and climate change popped to the top of the list of concerns among underwriters, and that was a surprise and very unusual. It usually was something that the reinsurance industry focused on, and that your direct underwriters said, we can adjust our policies on a one-year time horizon, no big deal. Well, now they're saying, well, 1 year may not be quick enough. If you want to rebuild your house after these wildfires in California, guess what? You're finding out that the insurance premiums are going up if you can get coverage, and chances are that coverage is much less than it used to be. And even to the point where some companies, AIG, for example, if you want to have fire insurance in these areas where there are more fires, you actually have to buy into their private firefighter company. And that should raise alarm bells in terms of the equity of that. If you're rich, you can do this. If you're not, you got a problem. And that's where people will start to raise their eyebrow and say, okay, something is amiss here. But I look to the insurance sector. They can monetize this in a way that ripples through the economy. They can also change public opinion. I find that more people will be influenced by a report from Munich Re or Swiss Re, or even their underwriter, Liberty Mutual, State Farm, others, that says this is a problem, where they might be dismissive of the IPCC. Well, those are scientists. Somehow they've become seen as biased, which is unfortunate and not true. But we're talking about public opinion here. But then when people hear, oh, wait a minute, insurance companies, they don't have a political dog in this fight. And yet they're just looking at the numbers and saying, the numbers are going up. You're finding that insurance companies are throwing away actuarial data, like from 10 years and before. It's not very useful anymore. Past is no longer prologue. We're in a new normal. And they're hiring climate scientists to figure out how they can price their instruments to provide insurance. That is an important, and you want to talk about not front page news, although it is showing up on the front page of the Wall Street Journal and elsewhere. We are seeing a shift in the market. And if you really want to change a company's behavior, affect their cost of capital. And insurance companies are doing that. And that, to me, that's an important shift, where maybe government isn't going to get their act together and do this. Insurance companies may do it for them.
I actually called into the Rush Limbaugh show 25 years ago when he was talking about climate change. And one of the things that I told him is that we're going to see insurance companies get involved in this. And if there's any economic power that could possibly challenge the power of the fossil fuel industry, it might be the insurance company, because they've got maybe not more money than God, but approaching that. Dr. Emmanuel, who you saw earlier, turned me on to this webpage, which I think is a good starting point for people who want to begin to protect themselves against these kind of events. It's called floodfactor.com. If you go to floodfactor.com, you can, in that space there, type in your home address or any address in the continental United States, and it will tell you what the projected flood risk for that address is going to be. Is it going to change over the next 30 years? And so if you own property, if you're thinking of owning property, if you're thinking of buying property, might not be a bad idea to plug it into floodfactor.com and just see what shows up, because certainly over the coming 30 years, over the life of that mortgage, we're going to be looking at some pretty significant events. They're not slowing down. But we are working on solutions, not just ways that you can protect yourself, but ways that hopefully we can head off some of the worst effects. And I want to make this point very forcefully. We have had an epidemic, I think, of what I would call climate doomism over the last few years. I have spent, whereas 10 years ago, I had to spend most of my time pushing back against climate denial talking points, more and more I am having to spend time pushing back on people that have gone too far in the other direction, like we're screwed no matter what we do, we're all doomed, it's all over, and just, prepare for the end. This is not what the science is telling us. And we have the power. When we look at these graphs of temperature or sea level or climate impacts going out to the end of the century, what we see is we see larger and larger bands going out to the year 2100, meaning uncertainty. The source of that uncertainty is not that we don't understand climate science, it's that we cannot predict the position, the solutions that humanity can potentially apply. We have the solution. The question is, will we apply it, and will we apply it in time? this is go time. This decade, the 2020s, is go time. So if you've been anybody that has been having any interest in the environment, any interest in politics, any interest in current affairs, any interest in, a social action or getting involved, and you're still waiting around for the right time, this is the right time. And fortunately, what we're seeing uh, in our big electric generators across America, across the heartland, and here in Michigan, is over the last 5 years, we have seen an enormous pivot towards renewable clean energy. It's not complete yet. They're not where I want them to be, but it is amazing. I remember having a conversation with Skip probably 5 years ago, and we were sort of bemoaning the terrible climate position and clean energy positions of our major utilities in Michigan. That has changed. So I'm going to show you a video here. You'll see Patty Poppe, who was up until a few months ago chairman of Consumers Energy. You will see David Sagow, who is CEO of one of Minnesota's largest utilities, and you'll see some other experts talking about this change and why it's economics and technology that are driving it. And that's very important. It's not just good intentions. It is hard economics that engineers and accountants are telling their bosses why they have to move in this direction.
Post World War II, electric demand was at a huge steep incline. Farms were being electrified, factories were coming online, we were fueling this great economy, and we needed to build plants as fast as humanly possible. And the reliable, affordable fuel that was available widely was coal, and it did its job. But the formula has changed.
The coal fleet in the US is on average about 45 years old. And that's about getting to the end of their lifetime anyways. And when we built a lot of these things in the 60s and 70s, we had to build these massive plants to get the economies of scale to make electricity really cheap as electricity use was growing and growing and growing and growing and growing.
Demand flat at best, and if we do our job, it might even decline. The actual per capita usage can go down as buildings are more efficient, lighting's more efficient, HVAC's more efficient. We all know that. So given that, we have the opportunity of a generation to determine with what will we replace these big central station baseload power plants. We will replace them with modular renewables because it's smarter.
What we've seen in the past, especially 2 or 3 years, is a recognition of the impact of falling prices for wind, solar, and storage across the country.
If you don't have certainty in your demand curve, you don't want to take a big bet and overbuild a big power plant. And actually, without the increasing demand, that's just a cost that we would all bear. If we're going to build a gas plant, it's going to be 1,000 megawatts. That's the minimum, efficient size. And so that's the way we used to have to think about it. We don't have to think about it that way now.
Whenever these utilities go, to the capital markets to look for these things, it's hard to fund a gigawatt scale plant anymore. And we have, cheaper alternatives in smaller pieces.
And so if we can modularly add renewables, and we can modularly add those renewables to match demand more timely. At the right time, we can add the supply we need 2 megawatts at a time.
Wind and solar are the cheapest form of energy available to us and in the electricity system in the US, full stop.
To be honest, 10 years or so ago, when wind was first being developed in the upper Midwest, it was a very disruptive resource for us. We weren't very good at predicting when the wind would blow. The transmission system really wasn't up to par to handle the intermittency of the wind. And quite frankly, it was wreaking havoc with the economics of our baseload coal plants. So we didn't like it much in 2005, 2006 timeframe. Fast forward to today, we've gotten very good at predicting when the wind is going to blow. The transmission system is able to handle the intermittency of all of this wind. It has no emissions, it has no variable costs, it's relatively inexpensive. What's not to like?
Colorado, where I live, where Excel here is able to buy new wind and solar for less than the cost of continuing to run its existing coal plants. Situations like that are showing up even in the Midwest, where Northern Indiana Public Service Company made a similar announcement and is procuring wind and solar to a similar end now as part of its new resource plan.
In the past, you would see that natural gas has been extremely competitive in the resource that you would want to select, but when you start competing and you see cost declines on these renewable resources, you now see them being chosen over these long-term natural gas units.
Everybody in the world has consistently for the last 10 years underpredicted the price declines in solar in particular, but also wind, and now we're seeing that happen with lithium-ion storage as well.
In the past, we've tended to think of our baseload resources, our coal resources, as baseload, and every other resource being supplemental to that, regardless of what it was. Well, that's been turned on its head now. I would suggest to you that wind is quickly becoming the new baseload. And to be viable going forward, all other sources of generation must be flexible enough to be supplemental to the wind. Kind of an exciting thing right now. And you get your mind around that, it makes a lot of sense what we start doing with our other assets and other resources and why we're so committed to the wind.
So here's just an example of what they're talking about in terms of the costs coming down. This is a graph from just a few months ago from Lazard, which is a international accounting and consulting firm. They have the gold standard tracking of the cost of new electrical generation. Everything to the left on this graph is cheaper. Everything to the right is more expensive. You see utility scale solar and utility scale wind. Wind in particular has some of the lowest prices of anything going forward. That's because the price of solar has dropped precipitously, 90% over the last decade, and the price of wind has dropped about 70%. And just to give you an idea of comparison here, based on those recent numbers, new nuclear comes in well above what the cost of new wind is. New gas, still in the competitive range, but gas has some increasing problems, and it's, look out for the gas industry. And I'll just show you where the newest wind farm in my neighborhood, Isabella County, just came online maybe 6 months ago, and that's showing up right here. So extremely competitive. And I was just out there yesterday. It is fabulous. It's amazing. And I spent an hour talking to a farmer, total Trump farmer. This guy says he's the original deplorable. But we get along great because he's a huge proponent of wind. He wanted wind on his own farm, but before he did it, he told me yesterday that he called all of his grandchildren because this was their inheritance. He asked them, what should he do? And they said, Grandpa, go for it. Grandpa, do it. So last few questions, of course, everybody asks, okay, smart guy, what do you do when the wind stops or the sun goes down? I talked to a number of experts on this. Of course, Wolfgang Bauer is at Michigan State University. He's actually a nuclear engineer who's become a huge fan of clean energy. And he talks about what we're doing in Michigan and why Michigan is actually uniquely placed among states to begin deploying massive amounts of clean energy.
The remaining question is, of course, what do you do about energy storage, right? And fortunately in Michigan, this has been solved completely. We have the largest battery that I know of, at least in North America, here in Michigan, and it's called the Ludington Pump Hydro Storage Plant.
Ludington Pump Storage is the great engineering marvel, one of the great engineering marvels of the world. It is the 4th largest battery in the world. It has 6 units. I don't know how familiar you are, if you've ever visited, but you should, because it's gorgeous. It's the most gorgeous power plant in the world. On the banks of Lake Michigan, pumps water up into a 27 billion gallon reservoir, and we have the 6 largest motors in the world. Each unit has a 500,000 horsepower motor. And those 6 largest motors in the world pump the water up. They power the pumps that take the water up into the reservoir. And then when we need the power, those motors rotating in reverse generate electricity. 2,200 megawatts of carbon-free, emission-free, clean, pure Michigan power. Today, we fill the reservoir once a day. But when we have fully deployed those 5 and then 6,000 megawatts of solar, we'll have excess power in the day. California is dealing with this, and they're concerned about what do you do with extra power in the daytime.
In Arizona these days, between the hours of 11 a.m. and 2 p.m., we get negatively priced electricity from California. There's so much solar being produced in California, they can't use it all. They push it to Arizona during those hours and pay our utilities to take it off the grid.
And guess what we're going to do with it? We're going to pump and fill the reservoir at Ludington. And then we're going to use that reservoir to serve the peak load. And then at night, our wind farms generating extra electricity will also then refill the pond, and we're going to get to refill that pond twice a day because of the upgrade we've done on those motors. That is exciting. That doubles the capacity of that battery for the service of people of Michigan and the inclusion then in our clean energy plan.
So it's inspiring what communities like Traverse City and Grand Rapids and some others across the state and across the country have done in setting goals for 100% clean energy. And I fully support that. But it is very important to understand, and this is the last video, and this is the last point I'm going to make before we go to Q&A, and I know it's running long, but this is important. Fossil fuels have not given up. And for any of us to reach these great goals that we're setting in cities and urban areas, we have to win the battles that are being fought across rural America, because it is rural America where wind and solar are being deployed and where they are running into ginned up fake grassroots opposition that is organized by the very same people who I've been fighting about climate disinformation over the last decade and using the same tactics. So I want to show you, give you a glimpse of what I've been observing in township halls across Michigan over the last 3 years, because the fossil fuel people have very shrewdly observed that the choke point for deploying clean energy is at the county and township level, where these boards can be cowed and intimidated by organized, misinformed opposition, the same kind of opposition we've seen in the past to, say, Obamacare, and the same kind of distortions. I'll show you what this looks like.
This is Jas Nolan, an attorney who is frequently involved in anti-renewable energy efforts in the Midwest. Here, Mr. Nolan addresses a board in Burlington Township, Michigan.
Excuse me, sir. Has actually excuse me, sir. No, I agree.
It was Dave's
Well,
time.
then just shut the hell up.
It was Dave's original
All
time.
right, I'll call a meeting. Please do.
In January 2019, Mr. Nolan addressed the Isabella County, Michigan Planning Commission, which had just unanimously approved a wind farm permit, making what many listeners interpreted as a thinly veiled legal threat against the commissioners. Listen and see what you think.
I don't really do this type of work, but there will be other lawyers that will be lining up to take these cases on contingency fees. And they will be coming after the county. And, you know, if I was in their shoes, I'd be looking at Apex, Epsilon, the county, and each one of you. And I would really encourage the county to up its liability policy before you complete this project. Have a good night, folks.
Thank you.
Intimidation comes in many forms. At a planning commission meeting in North Branch, Michigan, a farmer stands up to read an abusive letter he has received from an anti-wind activist.
David, you're up first. You were the first one. I would rather you didn't read that letter.
Well, you weren't here at the township.
I already read the letter.
So you only made your perception. Can I read it?
You can read it if you choose, you think it's necessary. Please censor it.
Oh, I will. Did you read this letter? Yes. But anyways, I got that letter the day after Thanksgiving. Now I'm going to bleep out some of the words, but it shows you how degrading somebody is. It's pretty disturbing. But anyways, it's addressed to me. And then he says, then you must be one stupid blank idiot in a world where you're just a stupid blank farmer. He's a liar and a cheater, and he blanks everyone over. We don't need bullies in our town to get out and take blank face with you. Bold letters that says no bullies allowed. Now, how would you like to get that letter the day after Thanksgiving? And it's unbelievable. So anyways, the opposition is being coached to put fear and intimidate people in the community.
On the other side of the state, in Casnovia, Michigan, a township supervisor recently described what happened as the board pondered a wind farm proposal.
I am proud and disappointed of our township. Most have come to these meetings calm and polite, even though we have our own perspectives on how this will affect our township. However, we have had some rude and disrespectful behavior. We've had vandalism at the town hall, we've had vandalism to our sign, and most recently, we've had some disrespectful behavior to one of our board members at the township hall. The township hall was closed Tuesday and Wednesday this week to avoid harsh conversations. During this meeting, outbursts of any remarks will not be tolerated, and threats to township officials will be prosecuted. I know it's tough, but we all need to behave.
Because these guys like this and this Keith Martis or Kevin Martis or whoever the hell he is on his social page has got that negativity, that fear factor, and that's what they're trying to send a message instead of going after the facts.
The name Kevin Martis is familiar to anti-renewable energy groups across the Midwest.
I'm also a senior policy fellow at E&E Legal Institute.
E&E Legal is a Washington, D.C. based lobbying group which receives substantial funding from the fossil fuel and coal industries. E&E Legal is nationally known over the past decade for a campaign of intimidation and bullying against scientists and academics across the country, like Malcolm Hughes of the University of Arizona.
I think psychologically it has a somewhat similar effect to living in a police state, because you learn to be extremely careful about what you say where in a way that stilts and stunts the free expression that needs to take place in an intellectually combative field like science.
For his part, Mr. Martis denies receiving any compensation from the fossil fuel industry for his extensive work and travel over many years.
And I'm not a paid lobbyist, and I donate my time. Sometimes people will give me an honorarium.
Recently, on his Facebook page, Mr. Martis posted a recipe for anti-renewable energy activists who wish to influence township and county officials. He writes, "Your county commissioners will not be moved by facts. They will be moved by political fear. If your plan for success involves urging the county government to take steps that require some blend of courage and intelligence, you will lose." For whatever reasons, Kevin Martis, Josh Nolan, and others like them continue to work against the best interests of farmers, families, and communities in rural America, and against the well-being of future generations of Americans. But across the Midwest, the transition to renewable energy is only picking up steam. as more and more Americans step up to demand real energy independence with power that is clean, inexpensive, abundant, and ensures our children's future.
So, I want to, I'm going to end the formal presentation here and just we'll open it up for Q&A. And I know I went a little bit long, so apologize for that. But I want to open a conversation about how we can support this transition that not only has to continue, but has to accelerate massively over the next 10 years. And I'm looking for allies. I'm looking for people who are willing to get involved. I'm looking for people that live in rural areas or are willing to become involved in rural areas, because this fight involves you. It involves your children. So I want to open it up for questions here, but I'll leave you with some resources that I think could be very, very helpful in this. If you want to learn about and share resources about clean energy, wind101.info and sun101.org are websites that I have set up, which have large numbers of short videos, even much shorter than the ones you've seen here, that educate and inform from reliable sources about clean energy. Floodfactor.com is the insurance company website that I mentioned before. And for anybody that still has questions about anything related to climate, you can, of course, contact me directly. But climate.nasa.gov is a wonderful resource from the most credible scientists on the planet. And I would encourage you to not to rely on Cousin Fuzzy on Facebook or some joker with a blog. Go to climate.nasa.gov. So with that, I want to thank you again for inviting me. And for those of you that are still here, let's open it up to questions. I'm happy to answer them if I can.
So Peter, one question was from Tricia Denton. How climate resilient is the Ludington pumping station? Was it engineered to withstand the new normal, rain bombs?
Well, I think that's a great question. The nice thing about that facility is that if they get a lot of rain and it starts to fill up, they can dump some water. So it's a pretty resilient facility, and it has been recently revamped, re-engineered to the tune of about $500 million. So I think that we could call that a pretty reliable piece of equipment. And just for the record, this thing at full power puts out a capacity on the order similar to the Hoover Dam. So this is not a science project or some boutique idea. This is a full-blown industrial plant that gives Michigan potentially an advantage to really lead in this area. But yeah, go ahead.
Okay, there's one question from Michael Hertz. It's been reported there may be problems with the renewability of wind turbine structure at the end of their lifespan. Can you comment?
Sure. What you're seeing, well, of course, the towers and everything are steel, and they can be, of course, recycled. And the largest wind farm producer in the world has recently committed to making everything that they produce completely recyclable, create a circular economy in the wind area. That people have been concerned about the blades. What do you do with these massive blades? And up until recently, there really hasn't been enough of these blades available for any kind of an aftermarket to develop. But now you have companies coming online who are creating machinery where they can actually go to the site if a wind turbine is being decommissioned. They can take those blades, grind it up into material that is then useful for as a part of concrete and as part of structural materials and other things. So people are now starting to actually make money off this. And since we know that a circular economy, a recyclable economy is absolutely critical to any kind of a future that we hope to have, the people that are running these corporations, who are to begin with fairly ecologically sensitive people, not only we know they're working on it, we see the actual results in terms of economic activity springing up and the free market beginning to kick in to solve these problems.
There's two questions on lithium batteries.
Yep.
Can you see the chat, Peter?
I don't, let me see.
It just says, please comment on lithium mining in the US and the lifespan risk and recycling of lithium batteries. And one person's asked, what about the water demands of lithium mining?
Well, okay, so let's talk about that. So lithium, for those that don't know, is the primary component of the batteries that we use in all of our computers, all of our devices, literally thousands of doodads and gewgaws that are part of our everyday life. And currently, and I had to look this up 3 or 4 times just to make sure I had the numbers right. The current mining footprint of lithium compared to the current mining footprint of coal. Coal is we're mining literally 100,000 times more coal than we are mining lithium right now. Okay, 100,000 times. Now we're going to be moving to electric vehicles. That's happening, and we're going to use more lithium. The figures that I have heard for how much lithium we're going to need in coming decades call for an expansion of that by about a factor of 30 or 40. So you're still orders of magnitude, several orders of magnitude below what we're currently doing with just coal, not to mention oil and all that is planned for Arctic expansion of the oil industry and fracking, which, you know, Michigan is in the crosshairs for expansion of fracking in coming decades, make no mistake. And very important, once you use coal, it becomes a coal pile, a spent coal pile that we have 1,400 of these in the United States alone, 90% of which that have been sampled are leaking lead, mercury, arsenic, cadmium into surface waters and groundwaters. And so the ones that have become toxic dumps are now going to be problems that ratepayers and taxpayers are going to have to pay for in perpetuity, because they're not going to go away. Now, what happens to lithium when you're done with it? Well, lithium you can recycle, and that aftermarket is already evolving. And so there is a growing industry in recycling lithium. So the lithium mining is going to expand to a certain point over the next 10 or 20 years, but then it's going to reach a much more steady state as we begin to recycle not just the lithium, but the copper, the molybdenum, any number of the minerals that are used in the clean economy. Just about all of them can be recycled and have enough value. For instance, silicon for solar panels, also recyclable. So you're talking about, first of all, orders of magnitude different problem, and a problem that has a ready solution, as opposed to, say, burning more coal, burning more oil, or even, you know, more nuclear and nuclear waste. So that would be my position there.
Boy, that was a great answer. We have several groups, you know, that are working on clean energy for Leelanau County. And Jan Rogalski is here from Leelanau Energy. Jan, did you want to say any words to get more people on that bandwagon?
I just want to introduce us briefly. It's a nonprofit organization that goal is to transform the Leelanau County into 100% renewable energy, and it's a work in progress and continues to be.
Thank you, Jan. It is getting late, folks, and we still do have Mark. Peter, that was an amazing presentation. I want to thank you so much. Could everybody please unmute themselves and clap for Peter?
Please.
Bravo.
Zoom clap.
Well, I know a lot. I wasn't until just.
Okay. All right. Thank you, Peter.